To help kick this talk off, we built a short video. As you watch this video, I want you to try and imagine some of the new things that you might be able to do with WinFS. And with that, let's kick this thing off. What do you guys think of the video? All right, good. Glad you liked it. So, there's my video slide. All right. So, I got an hour here with you today to tell you all about this great new file system. I'm going to talk about three big things. So first off, I want to start with some questions that I've heard fairly often. I see a lot of people here that have come and stopped me in the halls, talked to me in the track lounge. And there's two questions I hear all the time. The politically correct version of the questions are up on the slide, but the way I generally hear them are, WinFS, didn't that project get cut? And WinFS, haven't you guys tried this before like 10 times? So those two questions I want to address right up front because I'm sure it's top of mind for a lot of you. Then I want to talk about what WinFS is from two perspectives, why we built WinFS and what it is from an architectural perspective. And then I want to spend the bulk of my time, this third section, value of WinFS, where I'm going to take as much time as I can and show you as many demos as I possibly can of interesting ways that your applications could use WinFS. All right, so let's start with some history. So let me ask you guys, how many people have been at these conferences since before 2000? All right, leave your hands up. How many people have ever heard the phrase integrated storage before? All right, good. So integrated storage, been talking about it for quite some time. Some of you have probably heard about a number of very public projects we've had in terms of integrated storage, and we've also had some that are not so visible to the public. But the vision for all these projects has always been the same. It's try and build one store for all my data. I guess the earliest ones were probably back in the early 90s. And WinFS really is about integrated storage. It's about bringing together file systems and databases and objects and pulling it all into one store. But we think we have some advantages here that some of the earlier efforts really didn't have. The first big advantage is the amount of data in the world. When the original file systems were being created back in the 60s and 70s, the amount of data that could be put onto computers was sort of upper bounded by how much data existed on paper. Most of the data that was going on computers was being copied off of paper onto a computer. But today, I can take a photo with the digital camera and sync it directly to my computer, or I can go to a website, I can submit an order that goes directly to a vendor without ever having to fill out an order form, or you could have a music artist that goes and records a new song that shows up as an MP3 or as a WMV without ever having to be on a physical CD. So what that means is the volume of data in the world that's digitally born, meaning that never takes paper form, is much, much larger. So the amount of data you now have to manage is much higher. The second big thing is that the mechanisms by which we chose to organize data have really changed. So when file systems were being created, we had this sort of physical model that we wanted to use for organization. We had files and folders. People knew about filing cabinets, they knew about filing folders, so we thought, let's just take those constructs and move them over to the digital world as well. But as we've seen over the course of the last 3 or 4 decades, we've seen that people like to organize data in much richer ways than that. People like to know that an order is related to a customer, and a customer attends meetings, and meetings happen in places, and places are where pictures get taken. And these sets of relationships that really aren't easy to model as containment, where one thing is inside another. And the third big advantage that we have today, that we haven't had in the past, is the amount of supporting technology that we can build on. WinFS is really building on the backs of some real giants. We've got real relational engines that we use in our databases. We have a real file system in NTFS. We have a great programming platform in the CLR and .NET. And all of those technologies together are what enable us to really accomplish integrated storage with WinFS. All right, so we were at PDC 2003. We came and told everybody about WinFS, great new relational file system, and then we went away for a while. And I'm sure a number of people took that as WinFS got cut. I promise WinFS didn't get cut. I still have a job. And if it does get cut, hopefully somebody will tell me. But we did change some things. So the first thing we changed was delivery. And this is probably the one that most of you have heard about. One of the big changes is we're not going to deliver WinFS in the main Windows Vista release. It'll be delivered out of band. It'll still be delivered as a Windows component. It'll be delivered as part of the WinFX runtime components that in a subsequent release out of band from Windows Vista. And one of the main reasons we did that was we needed time for feedback. As I mentioned, file systems have been the same for 4 or 5 decades now. And a lot of us working on the WinFS project, the way we think about it is this information model that we're about to change, the new model for managing data, is probably going to stick around for quite some time. In fact, a common phrase we use at work is that this is probably the only information model that our children are ever going to use. And so we want to take the time to get it right. So we wanted to make sure that we had adequate time to get enough betas out there to make sure that people could give us adequate feedback on WinFS. That didn't give us a hook to go and say we can go sleep for a couple extra years. We actually needed to get those betas out, and so 2 weeks ago we got the first beta out. That's the build that's in on your DVDs. And we'll be releasing more betas. We'll still be in beta when Windows Vista ships, and we'll ship WinFS after that. All right, so another change to the WinFS plans was this alignment with the Microsoft data stack. You may have heard Bill talking a little bit about this in his keynote as well. When we came and showed WinFS to developers at PDC in 2003, we showed this new set of APIs. It was this new way to manage data that was objects and relational and files, and we're going to bring this new set of APIs all together. We handed it out to everybody, and they said, great, why can't I use this against all my data? Why is this just for my file system? And so what we've done is we've refactored WinFS and made it so that the data access stack for WinFS is the same set of APIs that are going to work against all your data. And those are all going to be delivered as part of ADO.NET. So all the APIs I'll show you today are prototypes of some of the next generation ADO.NET APIs, and will be same across all these data sources. And the fourth big change was platform support. So we heard a lot of feedback at PDC 2003 saying if you really want people to build on this new platform, you got to make sure that they can run it on as many different operating systems as possible. And so one of the things we did is we took Beta 1 down level to Windows XP SP2. Actually, the builds that you have work only on Windows XP SP2. We're still figuring out exactly which platforms we'll release on. There's a set of tough trade-offs in terms of the features we can enable on each operating system. But based on what we hear from you guys, we'll make those calls as we get closer to release. All right, so hopefully those answer a couple of your tough questions and probably leave you with the big question, what is this WinFS thing? So I'm going to start with talking about why we're building WinFS and some of the value propositions, and I'll talk about the architecture. So, and I'm going to use as a backdrop here, I'm going to use those 4 themes that we had in the video, Unify, Organize, Explore, Innovate. Use this as a backdrop as I go through this. So let's start with Unify. What do we really mean by Unify? So we're rebuilding file system on top of a database. One of the things that databases can do that file systems have a tougher time with is storing rich types of data. And so that's one of the big WinFS value propositions. So why does that really matter? And the reason we think of is this concept we call islands of data. So I'll give you an example. I'm at this conference, been meeting a lot of nice people, and I'll get business cards. And I'll take these business cards and I'll go sit down at my desk and I'll say, all right, I'm ready to go keep track of this person, so let's go add them into Outlook, fill in all your information there. Then I'll look down at your business card and realize you have your instant messaging address on there, so I'll fill in all your information in Office Communicator. And then I'll say, maybe I want to do some business with this person, and so I'll go open our CRM application, add you as a customer or a partner, and go create an open opportunity. And then I'll realize that maybe we split lunch, and I'm a little bit of a cheapskate, and so I'm going to go open up Microsoft Money, I'll add you in as a payee, I'll go send you a bill for lunch. So now, we're going to go away, and I'm going to get a call from you about 4 months later, and you're going to say, hey, I changed companies. I don't work there anymore. I work at this new place. I got a new title. I got a new address. I got a new phone number. I got a new email address. I got a new instant messaging handle. And I'll be thinking, Jesus, where did I put that person's name? All that data I filled in. I now have to remember all those places. That's very tough for users because each of these applications have built these islands of data. They've each modeled contacts in different ways and hidden them inside their application. But not only is it tough for users, it's tough for developers. So, just to give you an example, imagine that you're a developer that's building a little app that helps people plan parties. I know you guys don't all build those type of apps, so imagine you're that type of developer. And you're building the first page of the app, and it says, here's your party, pick a start time, pick an end time, pick a place, pick some guests. And you say, all right, I'm ready to go put up a dialog box that's going to show the user the guests that they can bring to this party. And then you think, boy, how am I going to fill in the guests? And you really have 3 options for how to do this. So one is, you can go think of all those places that a user could have put that data, and you can go integrate with all of them. You can go write something that talks to the Outlook object model, write something that talks to Active Directory, write something that talks to CRM application, write something that talks to Office Communicator. You can pull all those different contacts back. Or you can be a little bit more lazy, and you can say, well, I think it's a lot easier if people just manage their contacts here. So let me just create a new address book, and I'll create a set of features where you just come to my application, can add new contacts, they can go organize them, they can go change the properties, so on. And your third option, you can be even more lazy and say, this is too hard, I don't really want to do this. And you'll cut the feature. And none of those options are very good. And the worst part about those sets of options is that they perpetuate the problem. It's what we call the data partitioning cycle, which really means the more that apps have islands of data, the more a new app is encouraged to go create yet another island of data and make it even worse for the N+1 developer. So one of the big value propositions of WinFS is allowing developers to model their data naturally in rich schemas so that you can model things that are much richer than just files, so not only can you store them, but so other applications can get to them as well. Organize. So you build a file system on top of a database. One of the things that databases are good at is handling relationships. So folders have been around for some time. Very valuable construct. WinFS supports folders as well. But there's a set of relationships that are much richer than that are very hard to model in the file system today. So I went a few weeks ago and went and talked with the Windows Media Player team. And I was talking to them, it's a sort of nice story. They were telling me about when they were starting off Windows Media Player and how they decided their data strategy. So they thought for a long time about just modeling data as being in the file systems. That users would come along, they would take their music, and they'd go organize it in folders, and that's what you would see in the application. But then they decided that that's very tough for users to understand, because users like to manage data in multiple ways. They like to say, this music track is by this artist, it's in this album, it's in this genre, it's in this playlist, and folders really can't handle that. So what did they do? They went and built their own database and dropped it in their product. And then a couple years later, they popped up and they said, what did this cost us? Well, it turned out that 2 years later, that little database engine was 40% of the Windows Media Player code base and 30% of their development effort, going into this thing that was essentially doing 4 or 5 sorts for them. And from our perspective, we view that as an indication that developers need more out of their file system. You need a file system where you can model data the way that you and your users think about it, and not pigeonholed into files and folders, so that you don't have to build your own data stores. All right, Explore. This is a fun one. So these days, there's been a lot of talk about search. And there's a lot of people that say, why isn't tagging and searching just enough? Right? People search on the web. Now people search on their desktop. There's lots of applications that help them do this. You can go tag things in lots of different places. Why isn't that enough? Right? So I was going to give you a little story to help explain what we mean by using the power of a query processor to actually allow you to do richer things than just search. So think about this. So think about this guy. He's a salesman. Let's call him Joe. And he sells printers. And he's a really, really good printer salesman. And his secret is that he has great customer service. He makes sure that anytime he has a meeting with a client, he's always there in person, prepared. Anytime he gets a message from one of his really important clients, he responds within hours. He's just really on top of his customers. And he's so good that he gets promoted. And now he is a manager. And so he's thinking, boy, I'm just going to apply all the things I did while I was an individual contributor to now that I'm a manager. So when he was an individual contributor, what he would do is he would be constantly tagging and searching. He would take mail messages as it came in, and he'd look at each mail message, and he'd run this little algorithm in his head. It says, who's this message from? Is this guy an important client or not? If they are an important client, let me go mark this for, or flag this for follow-up, and then I'll just go search for all things that are flagged for follow-up, and that's how I'll keep track of my mail from my high-priority customers. But now he's a manager, and he looks down at his mail, and he realizes that he doesn't even know who these people are. He's got 10 salespeople that work for him that are going off closing deals with new customers or with old customers, but with much more money. And now he doesn't know how to triage his mail effectively. Now with WinFS, we don't want you to tag and search. We want you to use the natural models for data to allow you to organize in one place and reuse that organization in order to query in another place. So you should be able to go into your CRM application and say, these are my high-priority customers. Anyone assigned to someone on my team, anyone with over $1 million worth of business, these are who my high-priority customers are. I put all that work into deciding who they were. And now when I come to my mail application, I want to be able to say, show me mail from my high-priority customers. I don't want to have to remember that set and keep paging it out. That's what we mean by Explore. It's really about leveraging the power of a query processor so you can leverage all this rich schema and organization and get access to the data when you want it. So the fourth value proposition we think of for WinFS is what we call Innovate, which is really about not having to build your own data platform. So I gave this example earlier of Windows Media Player and how they went off and built a database to help them do those 4 or 5 sorts because the information model wasn't rich enough. And so we've come a long way in terms of providing a better information model, but really to have a data platform that applications can use directly, you have to go much beyond just a rich information model. There's a set of services that applications now expect. So to give you an example of this, think of Outlook 2003. So in Outlook 2003, we introduced this great feature called Cache Mode. And for those of you that haven't used it, probably should. Very good feature. And basically what it does is it allows your data to remain in a mode they call always offline. So it used to be that when you're ready to go offline, you'd come up, you'd say synchronize, and all your data would come off of Exchange, come into this little file they called an OST file, and you'd work against your OST file until you were back online. Then you'd say synchronize again, and it'd go back up to Exchange. And now, you're always working against your local file, and it's always offline and always synchronizing back with Exchange. What that means for a user is you get a great disconnected experience. You just pull out your your network cable and you're off and running. But it also means that you get this very high-performant local experience. When you used to go into Outlook and say group by conversation, that sort and grouping was done on the server along with 1,000 other users, while your client sat there idle. And so by bringing that data locally, they were able to provide a much better experience for their users. Now what that means for WinFS is the bar has gotten raised in terms of what a data platform must provide. So I'll talk a bit more about WinFS and how we've designed it especially for building these types of smart connected, high-performant client applications with all the services you need to be able to build those rich applications. All right, so it's enough on value. Let's talk about what it actually is. So I'm going to walk through this diagram from the bottom up. Let's start at the bottom. So what is WinFS? Well, first off, WinFS builds on a set of what we call the integrated storage components. So I mentioned earlier, one of the reasons we think that WinFS is a lot higher chance of success than some of our past efforts in this area is that we're really not inventing everything all the way up and down the stack. We're leveraging a lot of things that are really very mature technologies. We're leveraging a database engine, a relational engine out of our database products. We're leveraging NTFS. I'll talk a little bit more about that in a minute. We are leveraging the CLR to provide a rich programming platform for WinFS, but we're really able to pull all these technologies together instead of having to build them all ourselves. Second big thing that WinFS is a structured item store, and we need a new information model. We've had files and folders for a long time, but as I just pointed out, they're not quite enough. We need to have more than that, and so we have what we call items and associations. And items and associations subsume files and folders. So a file is a type of an item, but there are other types of items too. Like I could have a contact, or I could have a mail message, or I could have an order, or I could have a house listing, which we'll talk more about. And associations subsume folders. So I have one association that's just like a folder. It's a containment relationship. But I have other associations that say things like this customer is related to this order, not because one is inside the other, but because they're just associated. All right, so it's this new information model, and in order to really take advantage of this new information model, we need to build a set of schemas, or a set of Windows types, as we call them, that really take advantage of the information model and put them in the box with the product. So there's a set of new Windows types, we call them the everyday information schemas, that you can leverage directly as you're building on WinFS. But more importantly, you can extend those types. You can go add properties to our types. You can also go and build your own types, and I'm going to show some great demos of that in a minute. So we've got integrated storage components, we've got a new information model, we've got some types that really showcase how to leverage that information model, and now we need that set of services to really make this a complete data platform that you can use for your applications. And one of the most exciting set of services is synchronization. So we've actually built WinFS from the ground up, assuming that it was going to be a store as an endpoint for sync. More importantly, as an endpoint for multi-master sync. So we expect that you'll be able to build these set of what we call sync adapters, for which WinFS will provide you with all the facilities to track changes, to manage conflicts, to apply changes back, to handle progress reporting, to relay conflicts back to the users, all the different things that you don't have to build anymore. And then you can hook these up to your data sources and bring things in and out of WinFS. So sometimes I tell people we're building a file system on top of a database, and the folks that have worked a lot with databases cringe a little bit. Because the first thing they imagine is, boy, you're going to put a database on hundreds of millions of PCs, and where's the DBA going to go? Right? You can't possibly ship a DBA with every copy of Windows, but everybody knows that databases need somebody to come along and say, this page is a corruption, this is which backup I need, or these are the queries that need tuning, these are the indexes I need. And we can't do that with WinFS. So we went instead and built a set of technologies to help make sure that you don't need a DBA with WinFS. So these are a set of technologies we refer to as what we call Guardian, that actually monitor the store and automatically handle things like page failures, like retuning indices, all different things that you previously would have needed a DBA for. All right, so it's integrated storage, new information model, new types, I'll add all these services, and I haven't yet mentioned that it's a file system. It is still a file system. We mean two different things by that. One thing we mean is that it's got the file system semantics, that users expect this to be a place where they can store their data, where they can go and say things like copy this piece of data from one machine to another, attach a piece of data to an email message, and so on. But it also means that users expect all their previous applications that used to work on their file system to continue to work. So I still need to be fully backwards compatible with Win32, and we put a lot of effort into making sure that that's all going to work great. And the last step is an API. So as I mentioned before, one of the big changes to the WinFS plans were, instead of having a new set of APIs for WinFS, we're actually going to leverage the ADO.NET APIs using a new set of technologies called entities, which will allow you to build objects on top of relational data. There's a set of talks I'm sure you're going to that will talk more about that. But what it means is that means two things. It means one, you get one set of APIs across all your data sources, and WinFS is just a data source like that. But you also get the value of all the innovation that we're going to put into that API with things like language integrated query and the link stuff will all just natively work across WinFS. All right. So now we get to the fun part of the talk. So for the rest of the talk, I'm going to try and go through as many demos as I can and show you a bunch of different ways that we think you could use WinFS. So as a backdrop for this set of demonstrations, we picked a scenario. We picked a real estate agent. So real estate agent's a good example because they manage a lot of data. They have a lot of contacts and a lot of different applications. They have a lot of different meetings, a lot of different applications. They deal with property listings, a lot of different applications. And we've got to try and bring all that data together and show why a real estate agent will get a much better experience with WinFS. And so we partnered up with Northwest Multiple Listing Service. They're the ones that handle all the listings for the Pacific Northwest. And we've built a set of experiences. And the idea here is that the real estate agent works at a company where their IT organization has come and built these set of applications and extended a set of applications to allow the agent to have a great experience with WinFS. All right. So I'm going to use the same backdrop, unify, organize, explore, innovate. In case you haven't noticed, we like those phrases. So let's actually start here. I'm on one screen, but not this one. All right, there we go. All right. So first off, tell you about the machine we're running on. So this is a Windows XP machine. It's running WinFS Beta 1. And it's the same builds that you have in your packets. And so when you install Beta 1, the first thing you'll notice is when you open up My Computer, you see these WinFS stores. And these WinFS stores, you can think about a lot like volumes. Right? So I can go click into WinFS stores. Let me actually maximize this. And you can go create your own stores. We create one for you called the default store. And you can go drilling into the default store. All right, so let me go find a particular folder that I set up here. So this folder, I just went and dragged in a bunch of different items from across the WinFS hierarchy to give an example of some of the types of things that a real estate agent might see here. So remember I mentioned the new item data model. I can store much richer things than just files. So what I'll notice here is I have some things that are just files. So I have pictures, I have documents, but I have some other things that aren't files at all. So I have email messages, I have contacts. Actually, if I flip to details, you can see some of the types. These things are actually real estate properties. So we've actually gone and modeled every real estate listing as an item in their store. So the real estate agent can go and manage those things along with the rest of their data. Right, so I've got all of my data in this one place, and I can kind of think about it in a file system sort of way. I'll show you a lot of different views on this data. This is one particular view, which also means that I can leverage my existing applications to work against WinFS. So when I do the next step of my demo in Redmond, we generally get a lot of applause and a lot of hooping and hollering, and you guys don't have to do that. The reason is because we've been working on integrated storage, as I mentioned, for a number of years now. And one of the things that all the previous efforts at integrated storage have sort of broken their picks on is backwards compatibility. How do you build a new information model and really offer users and developers a new way to think about data while still making it compatible with the old set of applications? So we've done a lot of work here to make sure that old sets of applications just work. So all I'm going to do is I've got Word 2003 installed on this machine. So not really an old application, but will count as our example anyway. And all I'm going to do is double-click on this document that's sitting inside WinFS, and Word 2003 should open right up. All right. Some people knew how hard this was. That was a lot of work. Word 2003 is actually one of our toughest test cases because they stress every aspect of the Win32 protocol. So we work really hard on making this one work. So great. So I have all this data, and I can view it kind of like files, but that's really not showcasing the value of schematizing data and unifying it in this file system. So let me bring up another application here. So there's this application we call StoreSpy. This is an application, we actually have it on your CDs as well. It's in the unsupported directory at the top of your CD. It's a tool we built for developers just to see what's inside their store and give you yet another way to look at the data in your store. And so here we just wrote some queries and went and said, I want to go and find all items in my store. And so this one off and looked and found that I have 7,300 odd items in my store. I have all the same items, so I've got these email messages. I've got some meetings. Let's see. I've got some of my listings. But what you'll notice is that this data is actually schematized. So what do I mean by that? Let's take an example. Let's go look at mail. So here in mail, I have this column called from. And what we did was we actually modeled from and to and CC and BCC. We modeled them all as relationships. So from is actually a relationship between an email message item and a contact item. And so what we're showing in this column is actually a join. And you can see that if I go to filter by contact here. What we do is we just go execute a query. It says join all the contacts in my store with this set of messages and show me the distinct list of contacts. That's what filter by contact shows. And so now I can start to see that I have all this data and it's related together. I can also go model new types of data. So for example, we modeled listings. Let's go see what a listing looks like. So here I have listings. Listings have a set of interesting properties. Let me make this a little bigger. So I have MLS numbers, I've got listing dates, and I have this column called prospective buyers. And prospective buyers is another column that is a join. And it's a join again with contacts. So when I come here and say filter by contact, this goes and joins all my contacts in my store with this set of listings where there exists a relationship called prospective buyer. I can have other relationships as well. So I can, for example, pick one of these more expensive, beautiful houses here. I can have these houses that have relationships to pictures. So I can go see that this listing is actually related to a set of pictures. So these are just some of the examples of types of relationships we can build. So I'm going to pause demo for a second, go back to slides, tell you a little bit about what you just saw. All right, so the first thing you saw was this new item data model. So we've got these items, we've got these associations, and we were coming up with this new information model. We sort of had three big things in mind. You need to be able to model more types of data than just files. We need to be able to have organization facilities that are broader than just folders. But we still needed it all to be consistent for an end user. We still needed something that an end user could click on. We still needed something that you could drag into a share, drag to a folder, copy to an email message. And so the core item data model consists of three main concepts. Items, those are the things that subsume files. They're the things that are the center of most of the user operations. They're the things that we back up. That's the thing we set security on. Those are all the things that you think about as your atomic units of data. We have associations. There's two main classes of associations. There's what we call common value relationships. These are ones where the association is based on a value. So I can say something like this document and this contact are associated based on this contact's email address. And then we have explicitly linking items together, which means that I say these two items are linked based on IDs. And the third main concept in the data model is extensions, which is the ability for someone else to come in, or a developer to come in, and add data to a set of WinFS items. All right, so another question I get fairly often is WinFS really a file system? I thought you said it was built on NTFS, and then you told me it was a file system. Which is it? And the truth is that it's both. It's built on WinFS, and it is a file system. So I built this slide to kind of walk through what we mean by that, since I know it can be a little bit confusing. So I'm going to start at the top and think about it from a user perspective. So from a user perspective, they're going to approach their machine, and they're going to see a portion of the machine that has NTFS data on it and a portion of the machine that has WinFS data on it. They'll see it as peers. The C colon, they'll go see NTFS. When they go to whack whack machine name, whack default store, like I was doing here, they'll go and see WinFS. They'll go and take some set of data and they'll migrate it into WinFS. They'll sync it in, or they'll drag it in, or they'll move it in whichever way they like. But the set of data that's stored in WinFS is going to be items and associations. So in NTFS, they'll see files and folders. WinFS, they see items and associations. Now, some of these items are what we call file-backed items. Those are a set of items that are files today. So something like a document or a picture or a music file are things that are files today where there's applications written that expect to see files. And then there's new types of items that we call non-file-backed items, which are things like a meeting or a contact or a mail message that are these new types. So for those file-backed items, we actually leverage NTFS to store the streams for those items. So there's actually a hidden folder on the NTFS side under System Volume Info where we actually store each of these file streams. They're named by GUID. But the key point is that from the NTFS side, the user isn't able to get to these, or we're going to make it as hard as we possibly can to get to these. For those of you that know how client-side caching works and some of the other technologies, we've taken this approach before in other cases as well, leveraging NTFS as a technology here without exposing it to the user that way. So when a user comes and requests a file, so in this case they came and requested a JPEG. I did the same thing with the document going to Word. They come and request a file. What we do is we go and figure out which item that is and map that down to a particular file stream. And we hand a real file stream back to that application. So when I said we were building on the backs of giants, this is a great example of that. The thing that the Win32 application gets in the end is a real file stream, which means has all the performance they expect out of the file system, all the things that all the semantics they need are there. We're hiding the fact that these things are actually being serviced by this new relational file system. Now, those of you watching closely will notice that there's a potential for a disconnect here. So I've got this application, and it comes and asks for this item called foo.jpg, and it's going to get a file stream back when the thing really is an item. And so what's going to happen is, once they close that file stream, we'll run a set of metadata handlers, a set of what we call promoters, that'll come and promote data out of the file and into the item to make sure that the two stay in sync. And then when someone comes in through the WinFS APIs and changes the item, we'll run the corresponding demoter that'll go and push that metadata back into the file. That's how we make sure that these two representations, the file stream world and the item world, stay in sync. These metadata handlers will get written by developers and like yourselves. All right. So that gives you a sense of unifying data. We've got this new item data model. We can build rich schemas. But let's talk about organization. Let's talk about some of the rich things you can do with relationships. So if we come back here. So we built this application called LifeJournal as sort of an example application for something one of you guys might build that really shows a different view of the data in WinFS. So this application is sort of built as a timeline application, sort of a digital memory manager that takes all my data, same data in the same WinFS store, but this time it shows it based on time as one axis, and on the other axis it shows these bands. And these bands represent sort of broad categories of information. So this is our real estate agent's machine. So she's got a handful of bands she's set up here. She has some query bands that actually get all data that corresponds to a query, all mail, all photos, so on. She has these two bands here, Myers and Smiths, that are actually bands that correspond to two of her clients. And then she has a couple of bands here that track some of her personal information, like one that tracks things that are happening in her home, and one that tracks some of the things that are happening in one of her hobbies. She's an avid cyclist. So as I look across, these blips actually represent activity. I can actually zoom in and out of this thing. Very fun tactile application. And I can go and open up one of these bands. So we're here in the cycling band, and first thing you'll notice is lots and lots of different types of data. So I've got photographs, I've got web pages, I've even got this new type called annotations, which is really just the real estate agent wanting to keep track of a piece of data, not wanting to find a new file type or anything like that. They just want to go and define these annotations, a very simple schema, and she goes and just keeps track of her odometer readings so she can see that in line with the data about where she was and which race she was in. So another thing you may have noticed here, let me zoom back out a bit, is these little buttons. These little buttons are the way this application chooses to represent events. So here I have a button that says kitchen finish. It's an event in my store. It's related to a set of items. And I click on this. It'll actually zoom in. I'll click one more to zoom in a little further. And it'll show me all the items that are related to the meeting kitchen finished. So I see here's a bunch of photographs of when the kitchen remodel was done. I can go click on kitchen work starts and go see some for when the kitchen work started. And I can start to navigate my store in this kind of navigational sort of way. I want to go from meetings to photographs and so on. I can also go build relationships. So for example, simplest type of relationship I can build is a direct link. So I can go and say, I want to link this one to this one and this one to this one. And now when I go look at this one, it'll go show me here's the item and here's some items that are linked to it. I can also do something I think is really cool, which we call representative items. So I have this problem today where I have a digital camera, and so now I take lots and lots of pictures. And a lot of times I'll go out and I'll take pictures, and I'll end up taking 100 pictures of the same thing. And people can only have, you have 10 shots of the same mountain, the same pose. It doesn't really change that much. What you'd like to be able to do is organize your data and say, let's pick one of these items to be representative of all the others. And so what I can do here, I zoom out a little bit more, say, let me take all these items, say they're really pictures of the same thing. I want to pick this one and I want to make that representative of all the others. What you'll notice is I can still get to all the other items, and this one item shows that it's got 15 items that it's representing. Now what I'm showing here is a new type of relationship that this developer has gone in and added to this application. So you can actually say, this relationship that says these things are represented. I didn't go create a folder or go create some other construct for trying to say this. I can naturally say these are representative of these other items. All right. So that's great for her personal life. Let's see what it means for the real estate agent in a practical perspective. So I said before these little buttons, I get to a good spot in time here. These little buttons represent events. Now, it's a real estate agent, and the IT organization here has gone and said, well, there's a special type of events that are really showings. These are events where I'm actually showing a listing. And so they get these little house icons. And I can go and preview a showing, and it'll go say, here is the listing that is associated with this meeting. And I can go and navigate from the listing and go see, here's the listing, and here's pictures of that listing. I can the real estate agent can start browsing her store that way. And she can also use this for doing rich organization. So for example, let me just grab this MLS ID. Let's go jump up here. I'm just going to search for that MLS ID. And what it does is it goes and searches my store, finds me everything that contains that MLS ID, including a set of email messages, photographs, other times I've shown that house, so on. You have to remind me which one I picked, actually. Yeah, okay. And I can go and take one of these email messages and say, I want that to be related to this showing as well. And so I can go and see, hey, these messages are now linked there as well. Or I may want to go organize in bulk. I want to say that really this whole query should be related to, oops, I didn't quite read it. This whole query should be related to this showing. And now I can go look and say, here's the showing, and it's got all these email messages and all the photos and so on, all directly related to it. And what I've actually modeled is a real query relationship. I haven't gone and taken a static set of things and said link these together. So now when I get a new email message with that MLS ID in it, it's going to be automatically linked to this showing, and the real estate agent can go and find it. All right, so let's pause again. Let's see what we just saw. So the first thing I showed was a set of schemas. So we have these new sets of Windows types, which are the set of schemas we'll ship with WinFS that are natively built to really exploit this new information model, this new item data model. We have sort of three broad classes of schemas: the PIM type schemas, set of schemas for information workers, and a set of media schemas. But the more exciting thing is that you can actually come and build your own schemas. And so the way you build a schema in WinFS is using XML. So we have an XML format here for the schema that we were actually showing. So here the IT organization came in and built a listing schema. It's got a set of rich properties. It's even got a set of nested properties, things like price entries. And I've got this one that's called a showing extension. It says I have a specialization of meetings. It says meetings are showings. And here's the property I need to show that they're showings. I need an MLS ID. So you hand this XML form to WinFS, and we'll do two things for you. One thing is we'll go generate a class for you. So all WinFS items are really CLR objects. So we'll go generate a listing class and a showing extension class. And we'll also generate the set of things we need in the store to be able to store that data. Let me just give you an example of what that looks like. If I come back here, it's another application that's on your CDs called Type Browser. The other application I showed actually shows all the items in your store. This shows all the types in your store. So in this particular store, I have, for example, messages. Oops. And I can go look at message. It's composed of these different properties. I can go navigate the type hierarchy. And I can also go see that we've defined a new namespace called real estate. And real estate has a property item type, which is what we're calling listings, that has a set of interesting properties. And I have an item extension type called showing extension, which has this property called MLS ID. Right? So now I've got all these new schemas that I've built and modeled new types of data, and in order for my real estate agent to be able to manage those. So let me give you a sense of what the information model looks like now. So I have the set of Windows types. So in this particular demo I've been showing messages, meetings, contacts. They have a set of relationships. So message to contact has from, to, CC, BCC. Contact to meeting has an attendees relationship. And then I went and extended it, and I added two big types. I added the listings type, and I added the showing extension type. The showing extension type extends meetings and has a relationship to listings. It's called listings shown. And listings have a relationship to contacts called prospective buyers. So why do you do this? Why organize data this way? Well, there's two big reasons why you would do that. One is that it'll make your data feel like it's self-organizing. By modeling your data how you actually think about it, when you organize data in one place, it's really going to be organizing data across your system, because you can now build these much richer queries. And so that's sort of the fundamental basis of the next theme, explore. So let's talk about that. All right. So explore. We've got query processor, built it into the platform. How can a user really go and use that? Or how can an application build interesting experiences? So I mentioned before, the column from is of type contact, so the system knows that we can go and look for join of contacts with messages. It's sort of the fundamental piece I'm going to use to build up some queries here. So our real estate agent is just like the sales guy I was talking about before, the printer salesman. And she's got really good customer service, and she likes to keep track of mail from her high-priority customers. And the customers that are most high priority to her are the ones that she's showing houses to in the near future. So let's go see how she's going to form a query for mail from her high-priority customers. So she's going to go to her meetings. And meetings has this column called attendees, which is also of type contact, which means I can go and say filter by contact. We've actually pivoted the view so I can see the types here. So I can go and say, just show me all the meetings that are showings. And just go show me the showings for today. All right. So I said she wants to build mail from her high-priority customers, or mail from people she's showing houses to today. So if I go and look here and say filter by contact, you know, it's a much smaller list. Because the join of this set of meetings with set of people is now much smaller. In fact, these are the set of people that I'm showing houses to today. So what I want to do is I want to save that query off. I'm going to save that off as, let's see, .209. These are people I'm showing houses to. Boy, I can't type today. These are people I'm showing houses to today. Ooh. Well, it's beta code. Try one more time. Actually, I'm going to do one thing. I'm actually going to switch boxes. All right. So let's try that one more time. So what was I doing? I did, let's find all meetings that are showings. Yeah, it's definitely beta code. Like I said, we need time for feedback and time to work out bugs. So let's go build the same query. So let's go showings. Let's pick showings today. Let's go take this list of people, save this off. People I'm showing houses to today. Hope we don't get an exception. All right, good. I only have one problem. It's pretty good. So we went and saved off a query, and it's a query for people. I come back to my mail view, and the system knows that we've schematized the fact that from is of type contact. So not only can I go and say, join this list of messages with my list of people, I can say, go find me all queries in my store that return contacts. So I just built this query called people I'm showing houses to today. So let me actually go and say, show me the mail from people I'm showing houses to today. So I started with 3,300 odd items, or 3,300 messages, and now I get 121 messages. So I've gone and built mail from people I'm showing houses to today. So why is that cool? Right, so there's a couple reasons why it's cool. First off, it was a query. So if I run this query again tomorrow, it's going to be a different set of people, different set of houses, different set of mail. If I add a new showing, it's going to be a different set of mail. But the other big reason is, this is what we mean by self-organizing data. That I can go into one application and go build this list of people, and go into another application and go leverage it in sorting my mail. So some other examples of what I could have done there. I could have done, for example, show me the mail from people I met with yesterday, or show me mail from anyone who's assigned a task to me, or show me mail from people who trained for this race with me. So I can build lots of these interesting queries. So let's actually go look at listings. To build some queries that our real estate agents really going to love. So first off, we have this set of listings here. I'm going to go build a few queries. So let's build one query, which is, let's find all houses that have a price greater than $1.5 million. These are what I'll call the 209 houses of the rich and famous. And now I've got this query for houses. So I've got listings, and I showed you before how you could see them in a file system-like view. I'm showing you here how you can put them in a data grid. But there's some better ways that you can go look at listings. Anybody have any ideas for a good way to show listings? So somebody caught it. So we went and actually built a virtual Earth view into this application. Unfortunately, the version that's on your CD doesn't have this yet. We'll get it out soon enough. But this actually goes and takes that set of listings and puts them on a map. So why is that useful for our real estate agent? Let's build one more query. So let's actually turn this off for a second. So meetings had this attendees column, which is of type contact. But meetings also have this column called location. And location is represented as the address of a listing when the meeting is a showing. So if I just filter down to showings, and I'll go find the ones today, now I can go save off this list of locations. So again, last time I looked at meetings and I saved off a list of people. This time I'm looking at meetings, I'm going to save off a list of locations. Nice way to go and organize data in rich ways. So these are houses I'm showing today. All right. So let's go back to our listings view. Let's drop back into our map view. And pretty sure most of the houses we're showing today are up here. It's a region we call Kirkland. All right, so now I've got all the houses. And down here we show, these are all the queries in my store that return listings. So I can go and say, let's take houses of the rich and famous. Let's color those red. Let's take houses I'm showing today and color those blue. And now our agent can come in and say things like, hey, there we go. I'm about to show you this house, and there's this house around the corner that I also wanted to be able to show you. Sort of a rich way to come look at your data across these sets of relationships. So that's nice and that's fun, but the nice part is everything I've been doing here is being stored off in WinFS. So I can actually come back, if I come back to my all items view, and if I go query for DAT209, you may have noticed I was being careful to use that everywhere. The set of queries I just built are actually items in my store as well, which means that all of my applications can use queries the same way as they use other data. So let's go back to LifeJournal. And one of the things we did here is we have the search box that actually pulls up all the queries in the store. So I can actually have LifeJournal now go look for something like, show me the houses I'm showing today. And I'll go build a band up here. So it's me showing these eight houses today. And I can go and say in LifeJournal, go find me all the items that are related to that set of houses. And this actually will go off and query my store and say, these are pictures of those houses, email messages of houses, these are all times that I've ever shown those houses. I can start to build these things across this set of applications. All right, what do you guys think? Wow. All right, good. A few more slides, almost done. So let me pause for a second. So one of the advantages to coming to these conferences is you get to see the future of what we're going to be doing, and in a lot of ways you get to see a lot of things that we plan to integrate before we've actually got them integrated. So I'm actually going to show you some of the code here for where we're heading with our ADO.NET Entities integration. Some of this isn't exactly what you see in your build today. This is the direction we're heading, and you'll see aspects of it in the builds you see today. So to give you a quick preview here, there's this new concept in ADO.NET called Entities, which allow you to go and build map connections to your store. There's a handful of demos at the PDC about this. And allow you to go do things like open a data connection, hand in your own mapping, and get back a set of objects. Now you can query over the set of objects using language integrated query or your text-based queries, but you also get a typed set of results. This is really fuzzy up here. Is it fuzzy up there? Okay. And you get this type set of results. So here I'm actually querying for customers with active status, and I'm going to get real customer objects back. I can go update those set of customers, hand them back to my store, and I get this nice environment for dealing with objects and data. So, and there's actually a talk, DAT312, which specifically talks about how we're building this for WinFS. But the nice part is that the WinFS APIs are directly built on top of this, or actually are these APIs, and just specialized to a set of WinFS objects. So this is a similar code sample out of WinFS, but using the WinFS namespaces. So I have a set of WinFS objects. They live in a namespace called system.storage. When I open a connection, instead of going and providing a mapping, you open a WinFS connection. The mapping in WinFS is fixed because we've actually mapped out what those tables should look like. And we specify WinFS connections by path because that's what's appropriate for a file system. You get rich queries over the set of WinFS schemas instead of schemas that you could have developed across all other types of data. And the set of things that happen, the set of schemas in WinFS all inherit from the WinFS type. So for example, if I'm dealing with an item, we have a rule in WinFS that every item has to live inside a container. And so when I create this contact, I have to give it a container ID. You can go to DAT310, which Ramesh Nagarajan will be giving, which is going to talk a bit more about today's APIs and what you can get out of that and all the rich set of data services that we've built there. So to just tie that together with what I just showed you, the example I showed you was listings I showed to people today. So what would the code for that look like? So first off, you'd have a new set of schemas. So you'd go get your ISV real estate namespace. You'd go build up that first part of the query, which was showings today. I'd say select all the meetings where the start time is greater than now and it's less than a day from now, and meetings that are that have a showing extension where the showing extension is not null. I would go and compose that query like we were doing in the demo and say, show me the listings where I'll join that set of listings with this set of meetings based on MLS ID, and then I can go and iterate through that set of listings. And that's sort of it. Those are the types of things that we expect people to be able to do on WinFS. All right, so innovate. WinFS new platform. We don't want people to have to build their own data stores anymore. Much of this part of the demonstration I'm actually going to leave to Ramesh's talk. He's going to walk through this in some great detail. He has some great demonstrations for how to build apps. He's going to focus on three main points. One is developer scenarios where you're just trying to leverage a rich data platform. You just want a place where you can go build rich queries without having to build your own data store. And he's going to talk about schemas and how you can actually build new schemas and how you can build on top of our schemas in order to build rich sets of items with rich sets of behaviors. And he's going to talk about smart connected applications and how you build sync adapters that allow you to bring data in from other applications and build that nice cache mode experience like Outlook has today. A little over time. All right, just to remind you of what you heard today. First off, I gave you some history, hopefully answered some of your burning questions. Integrated data, integrated storage. We're trying very hard to address not only the challenges of today, but the challenges we expect data to have in the future. WinFS was not cut. The first beta is on your DVDs. We'll be delivering out of band from Windows Vista. We talked about what WinFS is, the relational file system. It's got a new item data model. It has a rich set of services to give you a more complete set of data services on your machine. And it's aligned with the next generation set of ADO.NET APIs. And most importantly, we talked about the value of WinFS in terms of these four pillars: unify, organize, explore, and innovate. And hopefully, I left you with some ideas for new and innovative applications that you can build that are dramatically different from anything that people can build today. And this is where you can go to hear more. That's it. Thank you. So I can take questions if people want to go to the mics or call them out. Go ahead. Yes. Oh, that's a good question. I'll repeat the question. So the question was, we showed off Store Spy. Is there going to be some sort of end user functionality that's similar to Store Spy when we ship? The answer is yes. We're working with the teams in Windows to make sure there is an experience in the shell so that you get a default experience for managing your data. That said, we're really thinking about WinFS much more as a platform where the ways that people use it will be through a much wider set of applications. So we expect people to go build applications like LifeJournal that do new rich things, or build a virtual Earth application on top of WinFS and give people new views of their data. Yeah. Go ahead.
Is it correct that a file lives either as an NTFS file in the NTFS file system or as a WinFS file?
That's correct. So the question was, do files live either in NTFS or in WinFS? Is that sort of correct statement? Yes, it is. Especially from a user's perspective, the file goes in one place or the other. It's either in WinFS or it's in NTFS. You can make copies, obviously, and have two copies, but the same copy is not simultaneously living in both. The fact that we're using NTFS underneath is just a technology decision we made to not have to reinvent the wheel on terms of handling Win32.
Question back here.
Okay. What was that? There.
Yeah.
Okay.
Yeah, you haven't mentioned anything about the server side on this, and I'm confused. And also, you talked about the sync adapters, but what's it syncing with? You know, will it sync with this running on a server, or with things like Exchange or a SQL Server? Could you comment on that?
Sure,
please?
sure. So he was asking about WinFS Server and what our server plans are. So there's sort of two answers to that question. There's one part which is WinFS as a file system having a server analog. So that's the thing you need to be able to drag, set up a machine and drag WinFS items there for doing things like terminal services and doing, My Documents redirection and so on. And that's a set of technologies we're working on as part of WinFS. The other is actually handling server scenarios where you want to deal with much broader types of data than just WinFS data. And a lot of what we're doing with our ADO.NET alignment is aimed at that. So you can use one set of APIs against all your applications. Some of your data may live in WinFS, the set that's appropriate for end users, the sets you want users to be able to click on, and so on. And some sets you may just build as mappings to your SQL stores. Second part of your question was sync adapters. What can you sync with? So you can sync with anything. We've built sets of applications. In fact, the one that we showed with listings was syncing to a web service. The MLS guys, Northwest MLS guys, have a web service that has their listings out there. You could sync to Active Directory, sync to your CRM application, sync to whatever you like. The part that the sync services provide in WinFS is the set of services for the data in WinFS. So you can, when you bring the data from your outside source, you transform it, and then we'll handle things like applying changes, telling you about conflicts, making sure you're minimizing your set of conflicts, and so on.
But everything is working like a cache mode type of analogy, like you were talking about at the beginning.
That's how we expect developers to use it. I mean, there's nothing really that enforces that you have to be using it as a cache mode type of application. But yeah, we're sort of designing with that in mind. Yeah.
Okay, thanks.
Yeah, go this way.
What is the potential for schemas to proliferate and cause the same problems that we now have with multiple different file types? So that you have someone providing a schema for their data type, and then you providing a schema for your data type that's very similar but not compatible.
Yeah, that's a really good question. A lot of why we are shipping the Windows types is to help set up the ecosystem to understand shared data, so that the ecosystem can go and manage that problem. So, for example, we don't want everybody to go design their own contact type and not get the advantage of being able to build those nice people I'm meeting with today type queries. We want people to go build extensions to types so that the sets of types that are there, they'll be able to use. So, I mean, the best answer we have for that is we're going to provide this set of types you can build on and a set of best practices to hopefully show people the value of sharing this type of data, and that'll encourage people to go and do that. There's nothing that stops you from going and building a schema that exactly duplicates someone else's schema. We just hope you don't do that.
So how does this hold up in terms of efficiency with space usage? Does it depend on the types of data you have, or versus an NTFS? So if you have 2 gigs of data in NTFS, you move it to WinFS, is it more or less?
It's more. It's not substantially more. I don't actually have any numbers on how much more. 15-20% is what Quentin's saying. Yeah, and one of the things I mentioned was the fact we don't ship a DBA in the box. So one of the things we do to not ship a DBA in the box is we take periodic backups of sets of the data. So we actually increase it a little bit more in order to make sure that page corruption happens, we know how to get back from it. But yeah, it's some overhead certainly, but we hope it's not huge.
And what is the implementation of ACLs and security?
Yeah, so for the security model we picked for WinFS, that was one of the big things we wanted to make sure we did not innovate on. We wanted people to be able to leverage their existing security models, their existing authorization infrastructures, and so on, to be able to use WinFS. So an item from a security perspective is just like a file. It's a thing you secure, you set ACLs on it, they're just like NTFS ACLs. And sort of, it's meant to mimic the existing security world.
Thanks.
Yeah. I think I had one more at the mic there.
Does the beta that you're shipping include any kind of utility for backing up or restoring a store and its associated schema and any links it has to the NTFS?
It's a good question. We didn't have time to get that for this beta. We'll probably have something like that for the next beta. But we're also interested in having ISVs come and build interesting backup applications as well.
So you expose something in the API?
Yeah, there's a whole set of backup APIs to allow you to do both item-level backups and store-level backups. I'm going to take this one over here.
Will Outlook 12 be using WinFS for storing mails when it works in cached mode?
No, Outlook 12 will not. Outlook 12 is going to release, hopefully, before us, and the Vista timeframe will release after that.
Okay,
so it'll be a subsequent version of Outlook that will.
Okay, thanks.
I think up here. Go ahead. The question was, what about support for transactions in NTFS-based items? And so for WinFS items, we actually provide full transaction support, just like you would for any database applications. We do provide some set of that over files as well, although it has slightly different semantics. The file semantics are a little bit different. So, for example, it's more of a pessimistic concurrency model as opposed to an optimistic model and so on. Yeah. Any question here? Yep. In fact, what we consider the item to be is the item, the file streams associated with it, any extensions on the item, any links that are sourced at that item. All of that is considered one box, and it's one ACL that controls all of that. They propagate the same way. Here.
If I've got a couple hundred contacts in Outlook today, is there any way that I can migrate them into Beta 1?
Yeah, so actually that application I showed, the StoreSpy application, has a feature that actually imports your Outlook data so that you can have some set of data to play around with. So it'll bring in contacts, messages, and meetings directly from Outlook. It's actually using the sync adapters to do that. There's one back here.
I was curious, with the different schemas, you mentioned that you're hoping the community will manage that, but you are shipping default types. Does Microsoft see itself actually extending more types as you go and also serving as a single source for evolving those type systems? Because that seems to be where the most muck is going to come, is that it'll be like the registry where things will just build up.
Yeah, so certainly we'll extend the set of schemas over time. And a lot of that will be watching the ecosystem and looking for the places where having a shared schema is going to provide maximum value. So yeah, we expect Microsoft to continue to play that role, but there will always be sets of people designing their own schemas. We hope they design their own schemas.
Right. Okay. Thank you.
Any more? How about this one?
What database are you using? SQL Express or?
So there's a set of, he was asking what database we're using, what database engine we're using. So there's a set of relational technologies across the company that we're actually using bits and pieces of. So it's not exactly one code base that you can refer to. And it's also a subset of the database engine that's been extended in different ways, just sharing code across a bunch of different products in Microsoft. The core relational engine is very similar to the one that ships in SQL Server.
How do you bridge information from legacy sources? For example, you have JPEG files which have exit header information. How do you bridge that into the information of the object model support?
Right. So the question was, how do we bridge in the sort of metadata formats inside of file formats into item formats? And so what I talked about on the NTFS WinFS marriage slide was this concept of metadata handlers. I know I didn't go into a lot of detail there, but basically there's a set of promoters that go and are code that come and understand the file format and understand the item format and do that transformation. That's an extensible architecture, so people with new file formats can come build their own sets of promoters and demoters. We're out of time. One more? All right, quick?
Okay, well, basically what happens if someone uses WinFS,
Yep.
transports the file onto like a 2000 server and transports it back onto the WinFS?
Yeah, so that was sort of the other half of his question. Is one side of the problem is I need to be able to promote metadata in files into items. The other side is I need to be able to demote those things back into files. And so these people that will write these metadata handlers are responsible for making sure that they actually demote that data back so that they can survive transport across file systems like that. So I'll stay around here, and I'll also be in the track lounge later. So feel free to come by and ask questions that way. Thanks.